There was an Indian chief, and he had 3 squaws and kept them in 3 teepees. When he would come home from hunting, he would not know which teepee was which. So, one day, he went hunting and he killed a hippopotamus and a bear and a buffalo. He took the hides and he put each hide with each squaw. So one had a hippopotamus hide, one had a bear hide, and one had a buffalo hide. Well, after about a year, each of the 3 squaws had children. The squaw on the bear had a baby boy. The squaw on the buffalo hide had a girl. But the squaw on the hippopotamus had a boy and a girl. So what is the moral? The squaw on the hippopotamus is equal to the sum of the squaws on the other 2 hides. That was bad. Okay, so let's talk about Pythagoras. That was kind of a joke on the Pythagorean Theorem. Pythagoras is the Greek mathematician who showed that the Pythagorean Theorem was true for all right triangles. So he showed that c squared equals a squared plus b squared. And I do have another video on this lesson that actually shows how he proved it. Well, it shows a deductive proof for the Pythagorean Theorem. Now, the main thing that you're going to be doing with the theorem is finding missing sides. To do that, first draw a right triangle and label the known sides. It does not matter which leg is A or B. C is always the hypotenuse. It's going to be the longest side. Now you write down your equation. C squared equals A squared plus B squared. Put in the variables with the replace the variables with the known values. Make sure that the shorter sides, the legs, are on the A squared plus B squared side. Do not put them on the C squared side. And then you put the long leg on the C squared side. A lot of students want to just put the known values in for A and B. And that's okay if I'm looking for the hypotenuse. But if I know the hypotenuse, I'm actually looking for either A or B instead. So I need to make sure to put the hypotenuse value in on the left. Solve. Don't forget to take the square root at the end. So in this example, the hypotenuse of a triangle is 50 centimeters, and one of the legs is 48 centimeters in length. We want to find the length of the third side. So here's my triangle, and it's always a good idea to draw one. And I labeled one side with 50 centimeters. This is the hypotenuse, so it's the longest side. This one's 48 centimeters, and I'm trying to find the short leg. Write down the equation. Now, here's the important part. Where does the 50 go? It goes here because it's the long side. And so I get 50 squared equals 48 squared plus x squared. Now, does it really matter if I had said x squared plus 48 squared? No, not really, because of the commutative property of addition. Okay, which means you can go 3 plus 4 is 7, 4 plus 3 is 7. Order doesn't matter on addition. Okay, so now I'm going to square both the numbers that I know, and I have 2,500 equals 2,304 plus x squared. Subtract 2,304 from both sides, and I get 196 is x squared. Now this side is not 196 centimeters long. I still have another step to do. I need to take the square root. And the square root of 196 is 14 centimeters. So 14 centimeters is the shortest side. In this example, I'm going to find the missing side in the triangle, and what I'm looking for, I'm going to write down the formula. C squared equals A squared plus B squared. All right, which means, remember, 7 is the long side, so it has to go in for C. 5 is one of the legs, so it can go in for A or B, your choice. And I'm going to call the other one I'm looking for X. Now, this is a little different notation than I did on the last problem. Why am I doing this? You might see some problems in the future where we say, okay, we're not going to actually do any of the multiplying or squaring, but we're going to show all the little steps in one move, in one expression or equation. So I can subtract 5 squared from both sides. Don't worry about getting your calculator out yet. I'm just going to write it as 7 squared minus 5 squared. Then I'm still trying to solve for this. It's squared, so I need to take the square root of both sides, which means that x is 7 squared minus 5 squared. So you're probably very uncomfortable because you're going, wait, there are all these numbers. Well, I could ask you a question where this is one of the answers. So this is one way to express it. But now, to make you more comfortable, I'm going to go ahead and square the numbers. 49 minus 25, which is 24. So x is the square root of 24. Now, I do have another part of this lesson where I talk about simplifying radicals. And I want to go ahead and show it to you now. Basically, when you simplify radicals, this will be important for Algebra 2. You need to pull out any numbers out of that square root that you can. And it'll also be important when we look at special right triangles later in the unit. Well, I know that 24 is 6 times 4. Now, why did I want the 4? I could have said 3 times 8, but I did 4 times 6 instead. The reason I wanted 4 is because I know the square root of 4. I don't know the square root of 3, and I don't know the square root of 8. Square root of 4 is 2. So I can actually write my answer as 2 square root of 6. Square root of 24 is the same as 2 square root of 6. So for further reflection, what relationship is true for the sides of all right triangles? And do you always add the squares of the two known sides? Why or why not?